All right, so next question. Typically, finding net force on its own is not the end-all, be-all solution. We are typically looking to use the net force for something. And so one of Newton's most famous formulas is called Newton's second law, and it has a few different formats. The one we're interested in right now is say the net force acting on an object is equal to the mass of the object multiplied by the acceleration. Now, in this case, we are looking for the acceleration. And the way that you could pick out this formula, if you look at your pieces, we've got mass that we should recognize because it says kilograms. Again, we just want to always remember that that's mass. It says forces, and these are newtons, so there you go. And then it's asking about acceleration. Now, we can't use the velocity and change in time for acceleration like we did in the other problem set because we just don't have that information. So that's how we can narrow down and see we're looking for this formula. We can do a little bit better because we know we're specifically looking for acceleration. We can do a little bit of brute force algebra before we start. We can take and divide the mass on both sides, and we can find out that acceleration can come from, instead of velocity divided by time, it could come from force divided by mass. The net force part here is just specifically to indicate that we have multiple forces that are acting together or against each other in some way, and we've combined those first. So I think this might technically be the first equation we've had, or rather first question we've had where we had to use multiple equations. Because unfortunately, I know something about different forces, I don't know the combined net force. So I will want to put that together. Dig a little deeper, use a new formula, see what you can figure out. All right, so initially I don't know where the net force would come from, but I read through, hey, they're pushing the sled, assuming that it's together in the most helpful way, so we can take and add their forces together. So basically pretend it's like one stronger person pushing instead of two separate people, whatever. But we want to find these numbers put together. Once we've done that, we finally are missing our last piece, and we can put it together, find a solution. So from our work so far, putting these forces and combining them, we get 511 point, looks like 23. And okay, well, that's not the final answer. It says acceleration, but I look, hey, that's in this formula over here. This was the problem I had earlier, is I didn't know that information. If I had known all along what that number was, then all I would have needed to do was plug in and it would be done. Good news is, though, that now that I have this information, we've worked it out, we can just get straight on there. All right, so that net force, 500, and I'll fix it this way, 511.23 divided by the mass of the object. So here, this is a sled that apparently has a mass of 12.33 kilograms. Evaluating here, dividing these out in the calculator, we get this about 41.46. Now the units we have to stop and remember, right? So newtons were a combination of kilograms and meters per second squared. And so what happens then is we divide the kilograms back away from this. What we're left with is just the acceleration part of the units, which conveniently is meters per second squared, and it matches. And so good news is that it gives us what we want. We don't need to do any additional conversions or changes.